Hi there, senior high school students. Welcome back here on my channel. This is Teacher Jinjin, your virtual teacher here on YouTube. This video is for grade 11 general mathematics. There are instances where the expression for the functions depends on the given interval of the input values. When this happens, we call these types of functions piecewise defined functions. We actually apply piecewise functions in our lives more than we think so. Tax brackets, estimating our mobile phone plans, and even our salaries with overtime pay make use of piecewise functions. In this video, you will learn the following objectives: define piecewise function, evaluate a piecewise function, write a piecewise function given an application, and graphing and interpreting piecewise functions. What is a piecewise function? To fully understand what piecewise functions are and how we can construct our own piecewise defined functions, let's first dive into a deeper understanding of how it works. A piecewise function is a function where more than one formula is used to define the output. Each formula has its own domain, and the domain of the function is the union of all of these smaller domains. We notate this idea like this. This is an example of a piecewise function where there is a domain 1, domain 2, and domain 3. For you to understand, let us take this an example. This is an example of piecewise function. The function is defined by pieces of functions for each part of the domain. As can be seen from the example, f of x is a piecewise function because it is defined uniquely for three intervals: x is greater than 0, x equals 0, and x is less than 0. How to read piecewise functions? Once we have a given piecewise defined function, we can interpret it by looking at the given intervals. If we take a look at this example, we can read it as: when x is greater than 0, f of x is equal to 2x. When x is equal to 0, f of x is equal to 1. When x is less than 0, f of x is equal to negative 2x. Alright, now that we have learned about this unique function, how do we make sure that we return the right value for the function given x? Here are the tips to remember when solving for and evaluating piecewise functions. For example, we have a given piecewise function. Evaluate f of negative 1, f of 0, and f of 2. First thing that you will do is to find where negative 1 lies in the given interval. Is negative 1 less than 0? Yes. Is negative 1 greater than or equal to 0? No. So, f of x is defined as 7x plus 3 for x equals negative 1 because negative 1 is less than 0. So, you are just going to substitute the value of x into the equation, and that is 7 times negative 1 plus 3. Then simplify. 7 times negative 1 equals, then copy positive 3. Simplify the equation, we will get negative 7 plus 3, that is equal to negative 4. So the final answer is negative 4. Reminder, double check where x lies in the given interval and evaluate the value using the corresponding function. Next, let us try number 2, f of 0. Since 0 is greater than or equal to 0, the function we'll use to evaluate f of 0 is 7x plus 6 for x equals 0 because 0 is greater than or equal to 0. And then, substitute into the equation, we will get f of 0 equals 7 times 0 plus 6. Simplify. 7 times 0 equals 0 plus 6, and then we will get a final answer, positive 6. Next, number 3, let us try to solve f of positive 2. So first thing that you will do is to find the interval where positive 2 lies. Is 2 less than 0 or 2 is greater than or equal to 0? It is greater than or equal to 0. So, we will use this interval 7x plus 6 because 2 is greater than or equal to 0. And then, substitute the value of x into the equation, we will get 7 times 2 plus 6. Simplify, 7 times 2 equals 14, then copy positive 6. Then we will get a final answer, 14 plus 6 equals positive 20. Now, as we have mentioned before, piecewise functions contain different functions for each of the given intervals. This means that when graphing piecewise functions, expect to graph different functions for each interval as well. This is an example of a graph of piecewise function. A solid dot means including, an open dot means not including. Have you remembered on how to graph intervals when you were in grade 9? When the given inequality is greater than and less than, we will use open circle or open dot. When the given is greater than or equal to and less than or equal to, we will use closed circle or solid dot. Again, when graphing piecewise functions, it helps to identify how each function would look like. And this is how we write it. F of x with a curly bracket. And then let us write this first graph. As you can see, we have here y equals x squared. And this is written as x squared if x is less than positive 2. It is an open dot means it is not included. So we will use less than. And then as you can see here in the second graph, y equals 6. It is written as if x equals 2, then f of x is equal to positive 6. Equals because it is included. And then we have here a third graph, y equals 10 minus x. And this interval is written as if x is greater than 2 and x is less than or equal to positive 6. Because this is a solid dot. This means less than or equal to 6. And this is an open dot. This means greater than positive 2. Let's try to graph this following piecewise function. As you can see, we do have 3 equations here. So what I like to do is to rewrite them out as y equals x squared. We have another equation, y equals 3. And then we have also an equation, y is equal to x. Again, this is written as y equals x squared, y equals 3, and y equals x. So, for all 3 of these, we're going to have to write any or draw any table. For example, in the first equation, if we have to make a table for the first one, remember, you must always include the value that is given to you. For example, in the first equation, we have x is less than or equal to 1. So, we will include positive 1. So, x squared, it says x is less than or equal to positive 1. So, we're going to include positive 1 as our first point. We also need to include a number that is less than or equal to positive 1, and that is 0 and negative 1. You can add here, but we are going to use 3 points only. Let's plug x in our equation. So, 1 squared is equal to 1. So, our value of y is equal to 1. And we're going to plot positive 1 in the Cartesian coordinate plane. And that is here. Now, that is going to be a closed circle according to our inequality sign less than or equal to. Our next value is going to be 0, and 0 squared is equal to 0. And it is in this point, 0, 0 at the center. Notice our line is going down to the left. When our x value is negative 1, our y value is equal to 1. So our line will go upward to the left. And that is negative 1, positive 1. So the graph of this first equation is like this. Next thing we need to do is when you graph our middle function here, make a table here. The good thing about our middle function is that it was given two values. So we're going to have positive 1 and we're also going to plug in positive 2 in our equation. So positive 1 and positive 2. Notice that the first inequality is greater than 1. So, we will use open circle. And for the second inequality, it is less than or equal to positive 2. So, we will use closed circle. And the graph is like this. If I will plug positive 1, our value is equal to positive 3. And if I plug positive 2, our value of y is always equal to positive 3. Because our output here is equal to positive 3. Connect these 2 points because we can't go any bigger than 2, so we don't want to go any further out past that point. The last one we're going to graph is x is greater than positive 2. Make a table and always include the given, and that is positive 2. Then include another number that is greater than 2. We will take positive 3 and positive 4. When our x is equal to 2, our y is equal to 2. When our x is equal to 3, our value of y equals 3. When x is equal to 4, the value of y equals 4. So here is the graph of this following equation. We have positive 2, positive 2, positive 3, positive 3, and positive 4, positive 4. And as you can see, our graph is an open circle. Our line is going upward to the right. Now that we have sketched each piece individually, we combine them together in the same coordinate plane and we will get this following graph. So combine all the graph in one plane, and this is the graph of this piecewise function. So that's it. Now let us try to solve these following word problems. Letter A. A user is charged 200 pesos monthly for a particular mobile plan, which includes 200 free text messages. Messages in excess of 200 are charged 1 peso each. Represent the monthly cost for text messaging using the function T of M, where M is the number of messages sent in a month. So here is the piecewise function of this following problem. We have T of M equals curly bracket and 250 if M, or the number of messages, is greater than 0 but less than or equal to 200 for sending messages of not exceeding 200. And if M is greater than 200, we will use this following piecewise function. Another example, we have a certain chocolate bar costs 50 pesos per piece. However, if you buy more than 5 pieces, they will mark down the price to 48 pesos per piece. Use a piecewise function to represent the cost in terms of the number of chocolate bars bought. So here is the following piecewise function. The chocolate bar will cost 50 pesos if n is greater than 0 and less than or equal to 5, or 5 chocolate bars or less. And then, if we will buy more than 5 chocolate bars, we will use this following function. If n is greater than 5, then the price of chocolate bar is 48n. And that's it. We are done with our first lesson about functions for our general mathematics subject. Great job for today! Please do consider subscribing and click the bell button for you to be updated on the next videos. If you like this video, please like and comment down below. This is Teacher Jinjin. See you on the next lesson. Bye!